Hello students, I am Dr. Preeti and here we are with the revision of concave lenses. In the previous video we have seen convex lenses and now we are going to have a look about concave lenses. Okay, so without wasting even a single minute we are going to start with our video. This is a concave lens. Okay, this is a concave lens and remember that concave lens is one in which the center part is thin and the outer parts are thicker. Okay, if you are wearing specs and if your number is negative, then you are wearing a concave lens, but if your number is positive, you are wearing a convex lens. Okay, so if your spectacles number is somewhere in negative, you are wearing a concave lens. Okay, it's thin from center. It's a diverging lens. Convex one, we already talked that it was a converging lens, but concave lens is a diverging lens. So if light rays are coming on it parallel to each other, then after refraction from the lens, they are not going to come closer to each other. They are going to diverge off. They are going to spread away from each other. Okay, so it's a diverging lens. To remember this, just remember one thing, that the light rays goes towards the thicker part of the lens, है ना. जहाँ पर भी लेंस मोटा है जिस पार्ट से, वहां की तरफ बेंड होगी लाइट रेज. तो in convex lens the thicker part was the middle part, so the light rays were bending towards the center part, and here the thicker part is the outer part. The light rays are going towards the thicker part, that is the outer part. Okay, why I'm telling you this to remember? Because in your like tests and all, I've seen that many students make mistakes and just they draw that the light rays are coming parallel to the principal axis, and after getting refracted even by a concave lens, that is passing towards the principal axis. So don't do that mistake. Don't land up with incorrect answers. Okay, so let's see about the rules. The rules are the same. uh, it's quite similar, not the same, it's similar to that of convex lenses, just is that it's a diverging lens. So this is our principal axis, this is optical center, and if a light ray is coming parallel to the principal axis, then after refraction from the lens, it is going to diverge off and appear to be coming from the focus. It will appear as if it is coming from f1. So this is rule number 1. Second rule, it's also having just 3 rules only. Second rule is that if a light ray, it's just opposite of the first one. If a light ray is passing through the focus f1, then after getting refracted from the lens, it will go parallel to the principal axis. It will go parallel to the principal axis. That is rule number 2. And rule number 3 is same for convex and concave lens. Can you tell me what is that? So this is a concave lens. It's the principal axis, it's the optical center. A ray of light that is passing through the optical center will go undeviated. It will not deviate, it will just pass on straight. I asked you in the previous video that why it's going straight, why it's not getting deviated. Okay, so just reply me in the comment section that why it's not getting deviated, why it's going straight. Okay, if you answer it correctly, I'll be really glad to see your answers. Okay, so now let's draw the ray diagrams for concave lenses. First condition is when the concave lens is there and the object is at infinity. How we show the object is at infinity? We just show parallel beam of light. Okay, so when we show parallel beam of light passing through a concave lens, that is the first condition, that when the object is placed at infinity. When the light rays are coming from infinity, then after refraction they will go diverge off If we trace them in the backward direction, they appear to be coming from the focus. They appear to be coming from F1, focus. So what we will write? Position of the object is at infinity. Position of image is at F1. At F1. Are the light rays really intersecting each other, or we are tracing them backward? We are tracing them in the backward direction. And that's why the image is formed at F1 is a virtual erect image. It's a virtual image when the light rays are not intersecting really. So it's a virtual image and it's an erect image. Okay. So virtual erect image formed at focus. Okay. So that is formed at focus. It's a point size image. Size of the image is a point size image. Okay, that was the first condition. In second condition, we are going to place the object anywhere other than infinity. We are not going to place it at infinity. We are going to place it somewhere that is not at infinity. You can place it at anywhere. You can place it beyond 2f1. You can place it between f1 and 2f1. The examiner will confuse you by these things. है ना? I can ask you that the object is placed at 2f1. So where is the image formed? The object is placed at f1 using a concave lens. Where is the image formed? So you can place it anywhere other than infinity. Your position of image will remain the same. Don't believe me. Just try it. Try to place your object at different points. Place it at beyond 2f1. Place it at 2f1. Place it between f1 and 2f1. Place it between O and f1 and try to get the image. You will be surprised to know that every time your image will be formed just at the same position. Thus, the same result will be there as we will see in this condition. Okay. So let's suppose we are placing it somewhere between f1 and 2f1. One of the light ray that is coming parallel to the principal axis after refraction diverges off appears to be coming from focus. So light ray appears that they are coming from F1 and the second ray of light that is passing through optical center will go undeviated. It will never bend. It will go off straight and the image will always be formed between F1 and optical center. So if our object is AB, the image formed should be shown by A dash, B dash. Always remember these points, okay? So the image is shown by A dash, B dash. What sort of an image is there and where is it formed? It's formed between optical center and F1. It's a virtual erect image. A virtual image is always an erect image. So it's a virtual erect image and the size of the image is smaller than the object. Okay, the size of the image is smaller than the object. Have you ever seen such an image in your life? Practically, have you ever seen this image? You all have seen, but it's not there in your textbook. So, in practical life, you have seen this lens, and this lens is there in the door hole. In the doors, there is a small hole through which you can see who is standing outside. Okay, so if a person is standing outside and you see through a door hole, you actually see the image of the person. Okay, so if this is your pizza delivery bhaiya, then this is the image. Okay, so always remember for a concave lens, if the bhaiya is standing outside, when you observe it from the lens, he will not get inside the house. है ना, कूद के वो घर के अंदर नहीं आ जाएंगे. तो इसलिए आप अपनी इमेज जब बनाते हैं, remember never draw it on the right side. Draw it outside the door only. Draw it on the same side as that of the object. Okay, so I hope this information was interesting. Hope these ray diagrams were good enough. Try to draw different positions of the ray diagrams always for every position of object using a concave lens other than infinity. You will get that the image is always formed between f1 and optical center. That is why in your book only two conditions are given, but the examiner will confuse you by asking where the image will be formed when the object is placed at f1 of concave lens. है ना, so f1 सुनते ही लगता है कि ऑब्जेक्ट इमेज तो इन्फिनिटी पे बनने वाली है, बट दैट इज ट्रू फॉर अ कॉन्वेक्स लेंस. फॉर कॉनकेव लेंस f1 पे भी ऑब्जेक्ट रखोगे तो इमेज कहाँ बनेगी? Between f1 and optical center only. Okay. So just keep revising your topics, keep studying, and score well in your exams. A very good luck.